So our next group has worked to solve a perennial challenge. How do we get young kids passionate and interested in STEM fields? So more specifically, they created an accessible game to captivate the minds of kids and to teach them programming. So please welcome Kindercode.
Welcome. Thanks so much for coming today. I'm Don, this is Sarah, and Soren. While brainstorming, we discovered that we had this common love for gamified learning. Kindercode aims to teach programming for children through fun challenges that build problem-solving skills at an early age. Kindercode is a visual programming language inspired by MIT Scratch. Let's get started. On the left side of the app, you can see orange and blue blocks. These are commands which can be dragged and dropped in any order to create a program. Programs determine the actions of the sprite on the right side of the app be executed with the play button. Whoops, looks like we hit a cactus. Let's try that again. The goal of each challenge in Kindercode is to create a program which moves your sprite, collecting all coins and avoiding all cacti. Great, we beat our first challenge.
So in addition to the basic movements you just saw, Kindercode also supports looping. Players can use a repeat loop to create more complex functions for their program. Players can also specify how many times they'd like something to repeat and can even nest loops inside of loops. For returning users, progress is saved in the database, so you can play a little bit now, come back later, and start where you left off. Kindercode also supports conditional if and if not statements. These are used on higher levels to collect a special red star. Kindercode was developed in React Redux. It uses React Drag and Drop and React Canva. SQLize and Express are used on the back end to manage level and user data. To teach programming, we had to create a language with grammatical rules simple enough for kids to understand. Soren will tell us more about that.
Thank you, Sarah. So the diagram behind me outlines the flow of data in our app, starting with the user's input and ending with animations rendered on the canvas. The journey begins with the drag and drop interface, which gives users access to the building blocks of our programming language. The user-created program is held on the front-end state in a tree-like data structure. To account for the potentially infinite nesting in our language, our interpreter recursively searches through the data structure, adding each action to an event queue in the order that they will be executed. We made sure to account for blocking so that each action would finish executing before the next one begins. In turn, each action triggers a re-render of our grid component with new information from the front-end state, causing the user's avatar to move over one space or collect a yellow, blue, or red star coin. Our group had a lot of fun making Kindercode, and we invite all of you to try it out at kindercode.herokuapp.com. Thank you. I hope you enjoyed our presentation.
Well, I liked it a lot. As a parent of a new kid, it's exactly the kind of application I would want to build for teaching my kid how to code. I also think that I like the design aesthetic and the programming language, because people oftentimes I want to make a game that teaches people how to program, and I tell the game mechanic that's exactly not fun is you're doing something like Fast and Furious, and then like a text editor window pops up. So I like how this one is very kind of iterative, and you got the code blocks right there, kind of similar to things like Scratch, but the language is even much more simplified. Oftentimes you give people too much power, they kind of shoot themselves a little bit. So very well done.
Yeah, I think they really struck a fantastic balance between accessibility and practicality. I am particularly impressed with the execution.